Okay, let's first integrate a function without using the hyperbolic functions. This was the previous integral, but how about this? X squared minus 1 is the negative of 1 minus x squared, but its square root is not. Okay, let's integrate its general form. Here x squared minus a squared should be positive, so x squared should be greater or equal to a squared, or the absolute value of x should be greater or equal to the absolute value of a. But if a be negative, since a squared and minus a squared are equal, so you could always choose a positive a. So the absolute value of x should be greater or equal to a. Now let's take x to be equal to this. Cosines always between minus 1 and 1, or its absolute value is smaller or equal to 1, then 1 over it should be greater or equal to 1. Or this, since this is equal to the absolute value of x, and absolute value of x should be greater or equal to a, so taking x to be equal to a over cosine t is a good choice. Now let's plug a over cosine t into x in the function and take a outside. 1 minus cosine squared is sine squared. Now we could get rid of the absolute value by taking sine and cosine to be positive. But x was equal to a over cosine of t, okay? So by doing that, we miss the negative x's, negative values of x, okay? But this is an even function, so its integral for the negative values of x would be its integral for the positive values of x. So here let's work with the positive x's, and the result for the negative x's would be just the result for the positive x's, and dx would be equal to this, and this integral would be equal to, now to solve it, one way is multiplying the numerator and the denominator into cosine of t, and writing cosine to 4 as cosine squared squared. Also cosine squared inside as 1 minus sine squared. Taking sine of t as u finally takes us to this integral, which could be done using the partial fraction decomposition like this. I'm not gonna find the constants here, but the integral would be equal to this, but the answer should be in terms of x, not u. So let's plug sine of t in u, then write sine of t as x like this, but we took sine and cosine to be positive before, okay? So plugging it into sine of t gives us the final answer, which is a crazy function. So let's see how to do it using hyperbolic functions easily.